Hello, 8th grade. We are going to be continuing part of our lesson from last week. We looked at um, observing chemical reactions and then describing chemical reactions. This is going to be part 2 of describing chemical reactions. And then on Thursday, we'll actually do part 3. There's just a lot in this lesson. So today is part 2. We're going to look at balancing equations. So I'll put myself right over here and hopefully that's not in the way. So balancing equations. So the total number of atoms of each element in the reactants, which remember is what you start with, must equal the total number of atoms of each element in the product, so what you end with. To be accurate, a chemical equation must show the same number of atoms of each element on both sides of the equation. Okay, so if I have hydrogen, which its symbol is H, if I have one hydrogen on the left side, so in my reactants, I need to have one hydrogen on the right side in my products. Okay, so there's 4 steps that you need to know when balancing equations. The first step is going to be writing the equation. The second, counting the number of atoms. The third, using coefficients to balance the atoms, which is as needed. And then number 4 is to look back and check. Okay, so first we're going to just get writing the equation. So first we'll read what our equation is going to look like. So it says chemical equation for reaction between hydrogen and oxygen that forms water. So the first step, to write the correct chemical formula for the reactants and the product. So the reactants on the left side of the arrow, separated by a plus sign. Then write the product on the right side of the arrow. So here we have hydrogen, oxygen, which forms water. Okay, so first step was just writing that. Second, we are going to count the atoms. So count the number of atoms on each side of the equation. A subscript tells you the ratio of elements in a compound. So here we have H2 plus O2, which gives us H2O. So with our H, we're going to have 2. Our O, we're going to have a number also. I think it's 2. Then we have H2 and O2 also. Okay. Excuse me, 1 O. Excuse me. So we have H2, 2 H's, 2 O's, and then we have 2 H's and 1 O. So 2 atoms of oxygen in the reactant here, only 1 atom of oxygen in the product. So how can we show that mass is conserved? Because remember, mass is neither created nor destroyed. So in order for us to show that the mass is conserved, we have to have the same number on each side. So let's go to step 3, using coefficients to balance atoms. So we need to get 2 O's on each side. Okay, so coefficient definition is a number placed in front of a chemical formula in an equation. So if the coefficient is 1, it does not need to be written. So we have an understood 1 in front of all of these. So we're going to balance the number of oxygen atoms by writing a 2 before the H2O. Okay, so then that gives us 2 oxygen atoms on each side. But then it also gives us 4 hydrogen atoms, because you take the 2 that are already there for hydrogen times these 2 is 4. So now we have 2 hydrogen atoms on the left side and 4 on the right, but we do have 2 oxygen atoms on each side. So we counted our atoms again. So now what can we do to make it even with the hydrogen atoms? Because our oxygen atoms are correct, 2 and 2, but our hydrogen, we have more in the product. Okay? So what can we do? We can put a 2 in front of the H2 on the left side. So then we take 2 times the 2, gives us 4. So we're going to count them again. So if we added that 2, now we count them, we have 4 hydrogen atoms, because 2 times 2 is 4. We have 2 oxygen atoms, we have 4 hydrogen atoms, and 2 oxygen atoms. So we look back and check, and that looks right. Right? So is the number of atoms of each element in the reactants equal to the number of atoms of each element in the products? Yes, it is. So if yes, the mass is conserved and the equation is balanced. So then the balanced equation tells me that 2 hydrogen molecules reacted with 1 oxygen molecule to yield 2 water molecules. Okay? So we're going to work on some other ones here. So remember our 4 steps at the top. So we're going to first just write the equation, which we already have written. So this one is going to be magnesium and oxygen. This is potassium chloride, oxygen, sodium bromide and chloride, and then sodium and chloride. Okay? So now we're going to count the atoms. So we know that since there's nothing written, the magnesium only has 1. There's a little 2, so we know oxygen is 2. And then the final, we have 1 and 1. Next, we have this one. So we're going to write all of our, or count all of our atoms first, excuse me. So we have 1 potassium, 1 chloride, and 3 oxygen. And then in our product, we have 1 potassium, 1 chloride, and 2 oxygen. So let's look at this one. We have 1 sodium, 1 bromide, 2 chloride, 1 sodium, 1 chloride, 2 bromide. Okay, that matches up. Then we have 1 sodium, 2 chloride, and then 1 of each in the end. Okay, so we counted all of our atoms. Now we're going to have to break them down to balance those equations. So we'll look at just magnesium first. So we need to get 2 oxygen on the right side. In order to do that, we added the 2, but then we also now have 2 magnesium on this side. So we have to add a 2 over here to get 2 magnesium on the side of the reactants. So if we count our atoms again, we get 2 magnesium, 2 oxygen, 2 magnesium, and 2 oxygen. Okay, we use the coefficients. Now we're going to look back and check. Oops. We look back and check, and they all match up, 2, 2, and 2, and 2. So that's correct. Now let's look at the next one. So we counted our atoms. So we need to get 3 oxygen atoms over here somehow. But everything else right now is right. So if we put a 3 in front of the O, take 3 times 2 gives us 6. Now we have to have 6 on the left side with our reactants. We take 2 times 3 is 6, so we put a 2 in front of this. Now we're also stuck then with 2 potassium and 2 chloride. So we added a 2 in front of here to get 2 potassium and chloride ones on the right side. So let's count our atoms. 2, 2, 6, 2, 2, 6. So we look back and check. Is that correct? Yes, it is. We move to the next one. So we have sodium and bromide each have 1. Chloride has 2. And then in our product, sodium has 1, which is correct. Chloride only has 1, which is not. And bromide has 2, which is not correct with the first part. Okay, so now how can we fix that? We put a 2 in front of the sodium bromide to give it 2 sodium, 2 bromide, and then we already have 2 chloride, so everything has 2 on the left side. And then we put a 2 in front of the sodium chloride on the right side to again get 2, 2, and 2. So we look back and check, and we are all equal, so that one is balanced. Okay, last one here. So we had sodium, which is 1, chloride, which is 2, and then sodium and chloride, which is just 1 of each. So we put a 2 in front of the sodium chloride at the right side with our product to give us 2 chloride, but now we need 2 sodium on the left side. So we have 2 sodium. We count 2, 2, 2, and 2. Look back and check. That's right. So we have our vocabulary word, coefficient, a number placed in front of a chemical formula in an equation. Okay, so for your assignment today, I know that was a lot. You're just going to go on Edmodo. There's a short quiz that's going to serve as just questions for you. And it's basically going to review what we looked at today with balancing equations. So some things are the steps, looking at an equation and determining whether it is balanced or not, and a couple other things. So I think there's 5 questions that you need to do. And then on Thursday, that's due on Thursday, and we'll come back Thursday for part 3 of this lesson. If you need more help, let me know, because I know that this is a lot.